Okay, what we're going to do is we're going to look at this idea called percent yield. It's really what it means is when you make a product, there's always going to be this theoretical yield. We'll call that theoretical yield the maximum you can get out of the reaction. Okay? And that's usually, if we say ideally, if everything reacts the way it's supposed to, we're supposed to get 100% of the product, kind of like a test. On a test, let's say it's worth 40 points. The test is worth 40 points. And let's say that you took the test, you got it back, and you scored 30 points. Well, that would be a 75%, because then you would take 30 divided by 40 times 100, and that would give you a 75% on the test. So it's similar to that concept. It's almost identical to it. Your test is based upon points, and again, your total points. This is what I'd expect you to get. You would expect to get all of the questions right, and this is the points you did get right, the 30 points. So it's kind of like a test, and that when you take a look at percent yield, there's always a certain amount that's 100%. You would expect that the reaction goes the way it should all the way, reacts all the way, and that would be a 100% yield. So hopefully that analogy kind of works for you. So here's the equation right here that you're going to use on all these problems. You've got three different variables. You've got percent yield. Well, if you find percent yield, it's really easy if you've got the actual and theoretical given to you, like the problem down below. The problem down below, it says, hey, your actual yield is 10 grams of ALP, and your theoretical yield is 30 grams of ALP. So again, like a test, if you're given both of those, it's really easy. Do those all the time when you get them back sometime to see your percentage. And that would be a 33% yield. Okay, so step back. What does that mean? That means that this reaction is supposed to have made 30 grams. For some reason, it didn't react all the way. It's limited at how much you can make. A lot of reactions are. We don't really get into that in this chemistry class. Other chemistry class realizes the reaction will only make up so much, and on this one it's 33%. All right. The next one, type of problem that you would get. Well, let's say that you're trying to find how much is actually produced in a particular type of reaction, and say that this reaction, the best it can do is a 92.5% yield. Okay, just because the way the reactants react, that's all it can make. And so we want to find out if our theoretical yield, that's 100%. Theoretical yield is always 100% yield. Okay, but we're only making 92.5. How can we set up our problem to solve for that? So what I like to do is I like to get rid of the percent, and the reason I do that is so I get rid of the times 100 on the other side of the equation. So I'm going to go ahead and point 0.925 is going to equal the actual yield, just like in our setup, divided by the theoretical yield. In this case, it's 222 grams of this is glucose. So we don't know the actual yield. Now normally I take that times 100 to get the percent. But if I don't have it times 100, then I've got the decimal form of the percent. So now all I have to do is get actual yield by itself, and I do that by multiplying both sides by 222. So then once I take and multiply that out, that's going to give me what we call the actual yield for this particular amount of product that can be produced. And so what you're going to do, you'll do these type of problems, which are really easy. They take very little time in which to accomplish. This answer would be 205 grams would be the actual yield. Okay, so we're going to take a look at two scenarios where we're using this same equation, but they're a word problem and it's based upon a reaction. So here's a reaction. We have the balanced equation. We just have to pick out what they give us. So there's three things in our equation. We've got actual, theoretical, and percent yield. So just like any type of problem in math, algebra base and that, you're missing a variable. So let's see what we're missing. So it says for the balanced equation below, the reaction of 49.6 grams of oxygen. So we have 49.6 grams of oxygen. So that's not a product, and so that's not any of our yield. These actuals and this theoretical has to be a product, and that's not a product. Okay, but we are given the percent. We're given the 42.5 grams of CO2. So that anytime they tell you how much is made, this is how much is made. Okay, this is going to be the actual. So we know the actual. The actual is 42.5 grams of CO2. Now, we're asked to find the percent yield, but the theoretical is not given to us. Well, but we can find it. All right? We can find it by doing a mass to mass. So this is a nice one because our formula masses aren't real big, and a lot of them you guys know already because we've been using them so much. So to find a theoretical, we just do a mass to mass. So we're going to go 49.6 grams of oxygen. Then we're going to change oxygen to moles. So it's going to go 32 grams of oxygen to 1 mole of oxygen. Then we're going to say in our balanced equation 5 moles of oxygen will produce 4 moles of CO2. And our last step is to go for every 1 mole of CO2, we have 44.01 grams of CO2. So that's that good old mass to mass that we've been working on a lot. And as we go through it, we'll go ahead and calculate that, and that's our theoretical yield. And then it's all it is at that point is plugging in those numbers like we did before. And I'm going to generate the answer here in a second. And your answer is 68 theoretical. That's not our final answer for the problem. It's 68.2 grams. Okay, so that's the maximum that can be produced. It's called a theoretical. And that's of the CO2. So then over here I'll put 68. Theoretical is always bigger because that's the maximum you can make. So then what I need to do is take the 42.5 divided by the 68.2 times 100, and I get 62.3% yield. Okay, so that would look like this. 42.5 68.5 grams is the actual yield, divided by 68.2 grams, that's theoretical yield times 100, and this is what I get, 62.3%, all right? And the last one that we're going to do is we'll put down everything we should have: theoretical, actual, and percent yield. So let's see what they give us here. So they give us the percent yield, and it is of and we're looking at HCl because it's saying how many grams of HCl can be produced. So we're looking at this, and so a percent yield of HCl in this reaction is 87.4% yield of HCl. All right, and then what it wants to know is how many grams can be produced or would be produced. All right, would be produced. That would be your actual yield. So they're wanting to know the actual yield. How many is going to be produced? All right, so we got this theoretical again that we have to do a mass to mass. So this is what we start out with. Here we have 99.5 grams of PClO5. And so then we have to go over here and find the grams of HCl. Alright, so that's what we need to do. Just another mass to mass. Seems like we do these all the time. And hopefully you know the steps, okay? Because they're the same for each one, just different numbers, different ratios. So we're going to go 99.5 grams of PCl5. And we're going to go ahead and give you the molar mass of that. It's 208.22. That's equal to 1 mole. Then we're going to look at our ratio. And our ratio says for every 1 mole of PCl5, we have 5 moles of HCl produced. For every 1 mole of HCl, we have 36.45 grams of HCl. That's the weight of HCl. Chlorine is 35.45 and hydrogen is 1, so that would be actually 4.6. Not that big a difference. Again, we'll calculate that number of grams. This is the theoretical, okay, which seems like we're always calculating that theoretical at some point, doing the mass to mass. And our answer is 87.1 grams. Remember, theoretical is always going to be bigger than your actual. So 87.11 grams is the theoretical. Okay, so after we do that, then we can plug that in here. Okay, and then like the problem above where we were given a theoretical and actual, if you can look up above, we're going to do the same thing. So on this one, where we got the theoretical and we're given the percent yield, we're going to do that same exact setup right there. Okay. So then we're going to go ahead and take the actual yield and make it the decimal form. So I'm going to go 0.874. Okay, and I'll try to separate this out so we're not confused on that. And then up above, I'm going to go ahead and I got to solve for that, actual. And the theoretical I'm going to put down here, 87.11 grams. So then I'll just multiply both sides by 87.11, I get rid of it. So it'll be 80.874 times 87.11 grams. And that would get my answer. Okay, so my answer is 76.1 grams. Okay, of HCl. Okay, so when you look at that, it just says an 87% yield of the maximum of 87 can produce 76.1 grams. Okay, so then I have an assignment for you guys to print off and look at and work on. And that assignment will look like this. And it's going to be attached. So what you have is you have free, easy ones where you got to plug them in. You're going to have two where you're given a percent yield and you'll have to find a theoretical. And you'll have two where you're given, where you have to find the percent yield. Okay, and then you can print those off and do that.